Welcome, ladies and gentlemen, to the Micronas presentation today about the HAL 15 switch family. My name is Caroline Kaiser. I'm one of the marketing managers here at Micronas and responsible for the switch product line. And the first information you should know about the HAL 15 is that with this product, Micronas provides the first ISO 26262 compliant low power HAL switch family in the smallest SOT23 JEDEC package. And here in this title you can already see that with this new product Micronas address a lot of new market trends and requirements. So HAL 15 is an automotive switch. For that reason it's AEC-Q 100 qualified as well as ISO 26262 compliant in order to address new standard or new quality and safety standards. Our design target was here to provide a multi-purpose device in order to address all main automotive applications, which are position detection, for example seatbelt presence detection, index counting, for example window lift application, and brushless DC motor commutation. So now let's take a deeper look into the HAL 15 specifications. So HAL 15 is the even improved successor of our well-known HAL 500 family, which has been standing since more than 19 years for best quality and highest reliability. And for sure, this we also claim for our latest switch generation. HAL 15 is provided as 2-wire version with current interface, which is preferred, for example, for applications like seatbelt presence detection, because it enables the customer to skip a wire for cost-saving reasons. And as 3-wire version with short-circuit protected open drain output, required or preferred, for example, for applications like bending light position detection. So then, with HAL 15, Micronas provide a device with a very low current consumption of typically only 1.6 milliamps and maximum only 2 milliamps, which is required, for example, for applications like door handle. And this very low current consumption, combined with our very low minimum supply voltage of only 2.7 volts, makes our device to the product with the lowest power consumption at all compared to all our competitors in this market segment. Well, and this supply voltage range goes then up to 24 volts, plus jump start and low dump capability up to 40 volts. And this is required, for example, for applications where the sensor is directly connected to the car battery, like clutch or brake pedal position detection. So then we provide here the smallest SOT23 JEDEC package, which is required, for example, for application with space restrictions like gear shift lever. And JEDEC implies that we have here standardized footprint positions and body dimensions, which enables easiest drop-in replacement. Then we provide the highest ESD rating with plus minus 8 kilovolts according to human body model. And this makes our device extremely robust against electric dischargement of a human person, either in the customer's manufacturing process or in the application itself, for example required for applications like seatbelt presence detection or seat position detection. So then for sure it's an automotive switch. For that reason it's provided with the best junction temperature range from -40 up to 170 degrees. And last but not least, as I have mentioned before, our device is AEC-Q 100 qualified as well as ISO 26262 compliant. Which means in our case, our device is an ASIL-A ready HAL switch, which implies additional monitoring features like our special and unique power on self-test, which enables the customer to test the full signal path inside the sensor before the ordinary operation starts. But this I will explain in more detail in a few minutes. Good. Now regarding the switching points, so we will begin with the starter portfolio consisting of 12 family members, including 7 different switching points for the 3-wire version and 5 different switching points for the 2-wire version. But in addition to this standard portfolio, we are also able to react to individual customer requirements and to provide customized derivatives. Thanks to factory programmable parameters, minimum order quantity is here 1 million pieces per year. Yeah, and these factory programmable parameters are the switching points for sure, first, programmable in a magnetic range of plus minus 30 millitesla in steps of 0.5 millitesla. Then the temperature coefficient, programmable in a range from 0 to minus 3000 ppm per Kelvin in steps of 100 ppm per Kelvin. Then the B-felt switching frequency is defined for the starter portfolio at 12 kHz, leading to a response time of 15 microseconds. But we are also able to provide higher B-felt switching frequencies up to 93 kHz. And this leads to a response time of only 4 microseconds. So, but, by the way, these 12 kHz are usually totally sufficient for the most of the applications. So, and then, last but not least, our customers can also choose between two low current levels. One from 2 to 5 milliamps and the other from 5 to 7 milliamps. So, now I would like to show you what are the improvements compared to the HAL 500 family. So, as you can see in this table, first of all, we reduced our minimum supply voltage down to 2.7 volts compared to before 3.8 volts. Then we have lowest current consumption with only 1.6 milliamps compared to before 3 milliamps. Then we have almost the same switching B-felt switching frequency because, as I've mentioned before, actually this 12 or 10 kHz are totally sufficient for the most applications. But at the same time, we reduced our output jitter from 4.6 microseconds down to 0.72 microseconds. And this contributes to an even higher threshold accuracy, which is especially required for example for applications like window lifter or electric sunroof with anti-pinch function. Yeah, and last but not least, we have here the SOT23 JEDEC package instead of the bulky SOT89 package. So now let's take a look on our competitors. So here again a table where you can see the difference. So starting with the minimum supply voltage, here you can see we are leading in this field with 2.7 volts. Then we provide the lowest maximum current consumption compared to all our competitors with maximum only 2 milliamps. Then we provide the widest junction temperature range, the highest ESD rating with plus minus 8 kilovolts. Then we have here, as I said, it's a mass programmable option. So at the moment we defined it at 12 kHz, but we are able to go up to 93 kHz. But at the same time, we provide here lowest output jitter of only 0.72 microseconds. So, and also linked to this B-felt switching frequency is the delay time or response time, which is at 12 kHz 50 microseconds, but with 93 kHz we can reduce it down to 4 microseconds. So, and then as you can see also here in this table, we provide the smallest SOT23 JEDEC package, while the most of our competitors only provide the bigger W package. So, and what I forgot to say about the 2.7 volts, for sure this also contribute to an error-free operation even during voltage drops. So, and finally, you should also not forget that with the HAL 15 we provide here the first ISO 26262 compliant low power HAL switch family here. So, and what does it mean, ISO 26262 compliant? I would like to explain now. So, in our case, that means we provide here an ASIL A-ready device. That means we are developing our device according to this ISO 26262 norm, which means to us a lot of new developing procedures and additional documentation for the customer at the end as part of the PPAP. So like the FMEDA or the safety guide or the fit rate, for example. So, but the modification or the development procedure is just one part that ISO describes. The other part is the modification of the device itself, and that means in our case we provide here a device with a single point fault metric, or in more simple words, a failure coverage of more than 60%. And this includes additional monitoring features like internal voltage regulator, under and over voltage detection, monitoring of internal bias and current level, monitoring of band gap, and monitoring of the Hall plate voltage. Plus our unique power on self-test, which enables the customer to test the full signal path inside the sensor before the ordinary operation starts. But this feature is optional, and for that reason it doesn't contribute to this 60% failure coverage. That means even if the customer would decide against this feature, he would still have this 60% single point fault metric. Good. So, and finally, our device is also able to communicate to the microcontroller failures or errors which occur via a fail-safe state. That means for the 3-wire we have a high impedance at the output, and for the 2-wire we have a very low current consumption. Okay, and finally, all this together makes our device to an ASIL-A ready Hall switch, which enable us to address ASIL-A or even higher classified applications by decomposition and embedding our sensors F meter into the customer's system F meter. So, and now I would like to explain our unique power on self-test. So, first of all, the purpose of this feature, as I've mentioned before, is to test the full signal path inside the sensor before the ordinary operation starts. So, and this feature, as I said, is optional. So, it's up to the customer to enable or disable the feature. Then we have, even during the self-test, the standard 1.6 milliamps current consumption. And finally, we are realizing our self-test without an additional pin, means with the standard 3-pin package. And how does it work for the 2-wire version, for the 3-wire version? I would like to explain now. So, to start the self-test, the sensor has to be connected over a microcontroller host, so that the microcontroller controls the power supply of the sensor. So to start now the self-test, the microcontroller needs to turn off the sensor and to pull down the sensor's output level to low level. So, and then afterwards to restart the sensor again and to release the output. And due to this order of events, the sensor realizes, okay, now I have to start my self-test. So because this is the command actually. So good. So then the sensor starts to imitate different kind of magnetic fields by generating an additional current through the Hall plates. So, and by doing so, the output of the sensor is forced once to switch to low level and once to switch to high level. And consequently, in a predefined period of time, the microcontroller has the chance to test once, okay, the sensor was able to switch the output to low level, and once, a bit later, that the sensor was also able to switch it back to the high level. And consequently, the microcontroller knows, okay, this device is working correctly, and after approximately 200 microseconds, the self-test is done, and the sensor goes back in its ordinary operation mode. So, and this is how it works for the 3-wire version. For the 2-wire version, it's a metal mask option. That means the customer decides with the order either to enable or to disable the feature for all power-ons. So maybe my explanation was a bit too fast, so but for this case I added an additional slide here in this presentation with a detailed written description of this power-on self-test. So, and finally, I would like to highlight again that we have here an SOT23 JEDEC standard package. That means we have here the smallest package, and we have standardized body dimension and footprint positions for easiest drop-in replacement. So, and yeah, so I hoped you enjoyed the HAL 15 presentation today, and in case of questions, please don't hesitate and contact Micronas service. So then, thank you for your attention and goodbye.
Micronas, managed by people, powered by ideas.